All right. Parallel lines and triangles. We want to use parallel lines to prove theorems about a triangle. And there's always good IXL, but these ones right here are just, as soon as you're done with the lesson, I want you to just F2, F3, F4, let's get those done. This one is a related topic, but these three right here are just boom. We're even going to make it part of the lesson today. So rate yourself. Some of you might know some things about triangles already. Rate yourself where you think you're at before we start, and let's take a look. Parallel postulate. Through a point not on a line, there is one and only one line parallel to the given line. So stop, draw a picture of what's happening. Through a point, so we have a point that is not on the line. So, well, let's draw a line first. So we're going to draw a line. Oh, there's my line. Okay, I need a point. Let's call this line L. Let's call this line A. There, I've set this part up. Through a point not on a line, there is one and only one line that's parallel to this. So if I draw this other line here that is parallel to it, we'll say that's parallel. These two are parallel to each other. This red line here is the only possible line that goes through A and is parallel to this. We could draw lines that are also parallel, like this line is also parallel, but it doesn't go through A. And this line goes through A, but is not parallel to L. This is the only one that goes through A and parallel with L. Kind of an obvious thing here, but it's got to be said. Okay, theorem 311. This is about a third of what you're going to learn today. If this is angle A, B, and C, the sum of all three of these angles, angle A plus angle B plus angle C, is equal to 180 degrees. And that's the rule. If you have three angles, and, well, if you know two of them, and you want to find the third one, you're always going to be able to do it. It's pretty nice like that. This is going to be used a lot this year. Now, I want you to, for this next part, draw a line here, and I'm going to call this angle 1, and I'm going to call this angle 2. And just to keep in accordance with what we're doing, I'm going to label this angle B. And you're going to go here to the next page, and we're going to prove that this is a true statement. So just trust me on this drawing. We're going to use it for the next problem. Here's mine. It looks like this. And I'm going to redraw what we just did. So we have this line here. This line is parallel with this line. We'll call this angle A, angle C. We put angle B right there. We're going to call that angle 1 and angle 2, just so we have everything. We know where it is. We know what it's called. Okay. Now, we're proving this, and it's kind of given that this line, you know what, I need to call it something. I'll give it J. That line JB is parallel with AC. This is a given. Now that you know this is given, do you see anything? This is where we're use the eyes. Just look. We're looking at that. I always draw this little, I don't know, kind of looks like Homer Simpson. Not in this time, but look at it. Find me some things that are true. What can we see that's true in here? Are there any angles that are the exact same size as each other? So, for instance, angle 1 right here. This angle, is there another angle in this picture that's the same size? Turns out there is. Angle A and angle 1 are the same size. So I'm going to write that down. Angle 1 is the same size as angle A, and it's because these are parallel. This is same side interior angles are congruent. And then over here, we've basically got the exact same situation. We've got this angle 2 and angle C. They're the same size. So angle 2 is the same size as angle C for the same reason. Same side interior. Angles are congruent. Okay. Boom, boom, boom. Those things were true. What else is going on up here? What do you notice about these three angles all together? You know, we're trying to prove, this is the end of our proof. I didn't put it in yet, but this is free. This is the end of our proof. We need something that involves 180, because so far we don't have any sayings that make 180. Notice angle 1, angle B, and angle 2. They would make 180. So let's go down here. Angle 1 plus angle 2 plus angle, not angle 2. There is no angle 2. Angle 1 plus angle B plus angle 2 equals 180. And this is, you could say, a linear pair, or you could say straight angles have a sum of 180. And you're set up there. Okay. Well, this is what we're trying to get. We're almost there. We need, our ending is A plus B plus C equals 180. What has to change? Well, 1 has to go from 1 to A. Oh, we have that right here. And 2 has to go from 2 to C, and we have that information right here. This is just simple substitution. Check mark. Proof is done. So we got, this was something we were given. We got this stuff by looking. We got this by looking. And then we just tweak one little thing, and the proof was done. All right, let's go on. Little vocabulary, and then maybe I'll do an example with you for my Excel. Exterior angle. So exterior, outside. An exterior angle is this right here. This is the exterior angle. These would be interior angles here. This is exterior. Okay. Well, remote interior. If the exterior is here, the remote means not touching, means far away. If you're using the TV remote, you don't have to touch the TV to use it. So our remote interiors are all these ones over here, far away. So angle 1 and angle 2. Those would be our remote interiors. This one here is our exterior, outside. Here's our theorem. This is pretty much the end of what we're looking at today. Let me change my line real quick. Triangle exterior angle theorem. The measure of each interior angle of a triangle equals the sum of the measures of its two remote interior angles. So in this picture right here, if I called this angle 3 would equal angle 1 plus angle 2. That is kind of a spoiler alert. The exterior angle equals these two over here. All right, let's draw a different picture of this. I'm going to draw this line. I'm going to draw this line. I'm going to draw this line right here. And I'm going to call this angle A, B, and C. And I'm going to call this angle 1, angle 2, and angle 3. So all the numbers are outside angles, and all the letters are inside angles. And there's going to be 3 statements that we can make about this. First statement, angle A and angle 1. We'll say angle 1 equals, now A is its next door neighbor. So it's definitely not equal to A, but 1 is going to equal B and C added up. B plus C, because they're the ones that are far away from it. Coming over here, we'll do angle 2. Angle 2 equals, nothing to do with C, because C's next door neighbor, those make 180. It's these two guys over here that we need to look at. A and B, angle A plus angle B equals angle 2. And then 3, angle 3 equals, nothing to do with B, it's angle A plus angle C. Okay, that's the end of our theorems for today. And what I'm going to say is, let's do a little IXL. I would like you to go to IXL, open that up right now. Just get each one of these at least to 50 right now. The triangle angle sum theory. All three angles make 90. Exterior angles. So angle 1 equals these two added up, and they get a little harder. I'll do one of these examples, and I'll go to a harder one, and then I'll just let you work. F2, F3, F4. That's where we need to be. So I'm going to jump up a level or two because these first ones are just a little too easy because they're just add or subtract. Here we go. This is a little more tricky. Nope, that's not what I want. There we go. All right. So this yellow angle is going to be the sum of these two angles added up. So you could write this all out. I just look at how many z's am I going to have right here. That's 2 z's and an 18 and a negative 32. Yeah, they are 18 and a negative 32. That's a negative number. That's negative 14. So minus 14 equals, these two added up equals z plus 48. Okay, it's a two-step equation now. Now you can solve it. Left side has more z's, and I'm going to add 14 and add 14. Minus the z, that's how that happened. Equals, adding these 50, what is that, 62? So z is 62. Put that in there. Now you could put 62 there, 62 there, and 62 there to finish solving the problem. But that's how this works. All right, I'm not going to bore you with any more examples. I think you can just attack this and get it done.